Okay, we're going to look at graph transformations. Parts 5 and 6. Okay, so let's look at part 5. Part 5 is the transformation when we've got y equals f of x and we transform it to k f of x. Okay, so for example, if we've got y equals f of x, what would happen if we then draw 3f of x? Well, there's previous experience that we've got with that from National 5. So if we think, if we've got y equals sine x, so that is 1 sine x, and then draw y equals 3 sine x, and here's what happens. So sine x goes up to 1 and minus 1, but 3 sine x goes up to 3 and down to minus 3. So what happens there is it stretches vertically. So 1 stretches up by a factor of 3 up to 3, and minus 1 by a factor of 3 down to minus 3. So things get stretched vertically by a factor of 3, both up and down. Okay, then we could have a scenario in which we've got y equals sine x. So that's again 1 sine x up to 1 down to minus 1. So what would happen if we had half sine x? Well, that would then compress it down to half and minus 1/2, so that would then compress it by a factor of 2. So y equals k f of x stretches y equals f of x by a factor of k where k is greater than 1. It compresses y equals f of x by a factor of k where k is less than 1. The stretch and compression is vertical. Okay, so here's an example. We've got the curve y equals f of x, which goes through minus 1, minus 2, and 4, 3. We're going to draw 3f of x. Okay, so it stretches the thing vertically by a factor of 3. Now, if you think about something that gets stretched vertically by a factor of 3, that'll affect its y coordinates. So it will stretch 3 up to 9, and it will stretch minus 2 down to minus 6. What won't be affected then is the x coordinates. That will have no impact. Okay, so let's have a look at that one, and it's going to be a vertical stretch of 3. So minus 1, minus 2 will now stretch down to minus 1, minus 6. And 4, 3 will now stretch up to 4, 9. The x coordinates will stay the same. Okay, so it's going to be minus 1, minus 6, and 4, 9. So a vertical stretch by a factor of 3, minus 2 to minus 6, and 3 to 9. Okay, next one. We've got the graph of y equals f of x, and we're going to draw y equals 2f of x. Okay, so y equals f of x goes through 1, minus 1, 5, 3, and 0.70. Okay, so 2f of x is going to stretch that vertically by a factor of 2. So 1 minus 1 is going to stretch down to 1 minus 2. 5, 3 is going to stretch up to 5, 6. And 7, 0, well, if you think about 0, if you stretch that up by a factor of 2, 0 times 2 is still 0, so that's still 7. And the curve will now look like that. Okay, we've put to k of f x. We're now going to look at f of k of x as opposed to k of f of x. Okay, so this is a different transformation. Okay, so f of k of x will compress f of x horizontally by a factor of k, where k is greater than 1, where k is less than 1, the horizontal adjustment will be a stretch. Okay, so again, we've seen this before from National 5 with trig curves. So let's think about y equals sine x. So y equals sine x, we've got a period of that goes from 0 to 360. But y equals sine 2x will then compress the thing horizontally so that we get two curves in 360. So as opposed to one curve, there's now two curves in 360. Or, for example, y equals sine 3x. It's then 1, 2, and 3 curves in 360. So it's a horizontal compression. But if we had, for example, y equals sine half x, then that would be a stretch. Okay, so it would be half a curve in 360. Okay, so there's y equals f of x. We're going to draw y equals f of 2x. So that's going to compress the thing horizontally by a factor of 2. Now, if you think about horizontal compression, what does that affect? What does it not affect? It affects x coordinates. Okay, what does it not affect? Y coordinates. Okay, so it's a horizontal compression. It's not going to affect the y coordinates, but affect the x coordinates. And if 4 is compressed horizontally by a factor of 2, brings that into 2. That's going to be 2. 12 minus 6 is going to be into 6 minus 6, and 1810 is going to be compressed into 910. Okay, and then I just draw the thing in, and it should have a look of being squashed horizontally. And there we go. Okay, here's the next one. Y equals f of x, and we're going to draw y equals f of 3x. So again, that's going to compress the thing horizontally. So 3, 0 is going to compress into 1, 0. 6 minus 2 is going to compress into, well, 6 divided by 3 is 2. 2 minus 2. And 12, 4, well, 12 divided by 3 is 4. That's going to compress into 4, 4. And it should have the effect of being compressed in quite significantly. So let's have a look at that one.